Okay, to wrap this part up, we're going to look at putting this stuff together from our part 1 to part 6 now. We're going to kind of put everything together now into one big chunk and see kind of how things are working with each other. So we're still doing functions and relations. Remember, a relation is kind of like a relationship, something similar to something else. A function is, remember, for every input, I get exactly one output. So let's think about this. You might have to stop this video and you might have to write these down real quick, but that's fine. So we're going to take an equation, we're going to go from a table, and we're going to graph it. And we're going to see kind of the connections between these two. Now, our function, remember f of x is our function. This is what's going on. So remember, I want you to be very close to this. This 3 is the what again? That's that rate of change, right? Remember, that's that rate of change. That's what there's, at 3 is always going to be there, regardless. The -5 is something that, remember, like I said before in the last video, if you take out money or you take out a loan, you got to pay that loan back. Yes, you got to pay the loan back. Well, let's say, for example, this equation, you are in debt $5. Let's just say you borrowed $5 and then your rate is $3. So for every hour or every day, every minute, every second, you're getting $3. But you still need to pay back your loan. So that's kind of what this means. And this is actually going to be called something this time, but not until the end. So remember, we still have a rate of change. That's our rate of change. So, let's do this. Remember our t-table and our function, our output? So let's put some values in. What if we use 0, 1, 2, and 3? Just because those are easy numbers to calculate. Where are we going to put these inputs for? Here, right? So what's always going to be there? 3 parentheses -5. 3 parentheses -5. I'm just writing this down for visual people. You don't have to do this later on. What do we put it in for our first input? 0, right? What do we put it in next for our second input? 1, right? What about our third? 2. What about our third? 3. Okay. And you see how the -5 and the 3 are still always going to be there? So just do some math now. 0, what's 3 times 0? 0, right? What do you still have? -5. So we still have -5 at 0. So you owe money at 0 time. That's fine. You still owe money. Now, what's 3 times 1? 3 times 1 is 3. What's 3 minus 5? 3 minus 5, you see more negative, so it's -2, right? Okay. You put 2 in. 3 times 2 is 6. Minus 5 is 1. Oh, cool. So it looks like I'm getting some money. Now it looks like I'm getting some money. If we put 3, what's 3 times 3? 9. What's 9 minus 5? 4, right? No, 9 minus 5 is 4, yeah. It looks like I'm getting some money now. Oh, cool. So something happens between 1 and 2 that you're getting from negative and positive. Something's happening. Cool. Well, that's awesome. So we have our equation, we plug some numbers, we have our values now. So we have this, 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 and this. Well, why don't we take this and plug it over here. So now, let's take this and plug it here. So remember, we have our x's and we have our y's. What do you graph first? Remember, it's always x, comma y, right? Always. Now, what's our first point? 0. So isn't it 0, comma, -5? Isn't that our first point? 0, -5. Where's that here? Where's 0 at? Remember what this is called right here? This center, dead center, is called the origin, right? This is called the origin, the center, dead center. So, where's 0 at? 0 on the x is here. Where do we go now? Where do we go now? -5 where? On the y, right? So, let's do this. 1, 2, 3, 4, 5. So it looks like we're right there. So this point here is right there. This point here is right there. Next point. 1, -2. 1, -2. This time, on the x, 1, and where do we go? So we go over 1 and down 2. Okay, that's that second point. Where's the third point at? 2, 1. Where's that at? Over 2. And where do we go? Up 1, right? So we're going to go here. What's the next point at? 3, 4, right? 3, 4. 3. Remember, this is 1, 2, 3. And where do we go? Up 4. So over 3, up 4. What do you think's happening? What do you think's happening? What if you connect the dots? What if you connect the dots? Get a line. You get a line. A straight line. Well, you're probably thinking, what can I do with this straight line? Let me ask you something. Remember in this the last video, we did this. We took 2 points. And I want to get from this point to this point. What did I do? Didn't I go up, over? Didn't I do something like this? Up, over, up, over, up? Didn't I do something like that, like a staircase? How many get to this point? 1, 2, 3. So that's 1, 2, 3. So I went up 3. Now remember, run. 1 to 2 is what? From 1 to 2 is what? From 1 step to 2 step, how many do I go? 1. So, rise, over run. Isn't that 3? Well, look right here. There's your 3. So that is our rate. Is our rate. Well, can I go from this point to this point? Well, let's do it. 1, 2, 3. How many over? 2 to 3. 1. 3, 1. Same thing with this point. 1, 2, 3. Over 1. Huh. There you go. So, this is our rate. Up 3, over 1. Up 3, over 1. Up 3, over 1. And we can keep going. We can keep going forever. So, you've been waiting for this. This up and over, this y2, y1, x1. Remember our equation? We also said this is rise over run. This is also what we call the slope. This is what we call the slope. And this is, so this is our equation. This is our equation that we had over there. Our slope is 3. Our slope is 3. And that's what happened here. So all through 1 through 6, you're seeing this development happen from where we begin to where we end. And 3, this right here, is what we're working with. This is the working with of it. So I want to leave you off with this one thing. I want you to think about that real quick. So, what we're trying to develop is some kind of equation that we came up with here from this. And that equation that you're going to see a lot is this guy right here. That's our equation. This is our equation that we are going to be developed. Or we have developed. We're going to be working with. But one thing, what's the M called? Well, actually, a French mathematician, his first name was Montour, came up with slope. Came up with the word slope. He was a French mathematician, and his first name was Montour, so M. If it was an English mathematician, they would probably use S for slope. But since they were a French, they used their first name, which is their first letter. So we can't really change it because it takes a long time for something to change in math, but we all have to agree with it. But a lot of people recognize it. And we want to recognize the person that's really developed it. So this is what we call our slope. And this guy right here is for next time. It's called the y-intercept. or you can think of it like our beginning point, aka beginning point. But that's our equation. And sometimes you see it on my shirt. That equation is pretty much what we're going to be working with from now until the end. So y equals mx plus b. M is your slope. That was our 3 in our equation. The b is our beginning point. So remember when you took out that money, that $1 million, that was your beginning money because that's somebody that you had to borrow. That is where you start. Oh, so that's where you start. And that's the whole thing about this. So that equation is what we're going. And so I'm hoping that you're seeing a lot to this. So I see you on the next part. All right.